This is distillation. Distillation is going to be our separation method used to separate homogeneous mixtures based on the differences of boiling points. So what's going on here is we have a mixture of a rubbing alcohol mixture. It's about 70%, and I have it heating up, okay? And so as it starts to reach alcohol's boiling point, which is a lot lower than water's, the alcohol is going to evaporate, turn into a vapor, and it's going to move down this tube. As you can see, there is water that's coming from the sink. That water is cooling it down, so therefore it's condensing it back into a liquid, which will then be filling up my distillate or my flask. Okay, so once again, this is based on different boiling points. Okay. All right, this station we have chromatography. And so looking here, we had two solutions that we put our chromatography paper in. As you can see, the water did not really move the permanent marker up this chromatography paper. The alcohol, on the other hand, did. You can see it kind of went all the way down. So this is partially why you would use alcohol to clean up any kind of permanent marker. Not water. Water is not going to erase it. And so what it is it separates solutions like dyes. It's based on their different solubilities. Okay, and so you need chromatography paper, your solvent, and your ink. All right, and what we have over here at this station is going to be the centrifuge. And the centrifuge is this little device that's going to separate things based on their different densities. Okay, so as you can see in our little sample here, I've got some mud and water. If we just shake it up, make sure it's all mixed up like that, so you can see the sample right there. Okay, I'm going to put that into the centrifuge. This guy is just here to balance it. It's important for these things to be balanced. They go pretty fast. So we're just going to flip on the switch. We don't have to let it go super fast, so we're going to stop it right when it starts making some noise. Okay, so while that thing is slowing down, just to talk about it a little bit more, it's kind of like the thing at a fair that you go on. It's like, I think it's called like the Gravitron or something like that, where you stick to the walls. It's kind of like that. So what it's doing is it's pushing your more dense stuff to the outside, keeping the less dense stuff on the inside, and then you can see that it's centrifugal force. It's inertia, basically. So when we go to kind of look at our sample, I'm going to pull this guy out. You can see that it got separated. We got all of our dirt pushed down to the bottom. And that is the centrifuge. Okay, here we have magnetism. And so as you can see, my little sample here has some gravel and iron. It's really kitty litter and some iron mixed in there. Okay, and we have our magnet in a baggie. We do this because it's going to be pretty impossible to get it off the magnet if we actually do it that way. So plus it helps us get the fillings off a lot easier. So as you can see, they kind of gather up on that magnet, the iron fillings. Okay, I'm going to put this down to kind of show you how you're supposed to go ahead and drop the fillings. So you kind of work it around and you have your little fillings, and you would take it to wherever you're trying to place your sample. You're going to put it over that, and then you just pull the magnet, and now you've just released everything that you gathered. And I can take it all back like this, clean up my table a little bit, okay, and I can put it right back into the mixture same way. Okay, so that's pretty much the important thing. That would be the skill that you might need tomorrow in your lab. Okay, so just do that. Okay, so magnetism is going to separate things based on their magnetic properties. All right, over here we have decantation. This is going to separate a liquid from a larger matter. So what I have is, it's not really gravel, it's more like clay with some water, a water layer on top. Okay, And then over here I have a separation funnel with oil and water. So I'm going to look at that first. Okay, so here what we've got is we have a separation funnel. So you usually do this with different densities of liquids. And so really what you do is you pour that whole mixture in here. It'll separate itself, and then you just slowly allow it to fall, and you get some of the liquid out. Okay. Okay. And then the other type of decanting is more what you guys would do. And as you can see, it's done to separate your particulates from liquid by allowing the solids to settle at the bottom. So that's the big idea here. So when you go to decant, kind of a little different from the picture that's showing right here in that slide, I like to hold the stirring rod onto the beaker to kind of give it a little place to flow, and then I'm going to carefully pour it into the other beaker, and it kind of guides it and helps the solids to stop from flowing in as well. Okay, and so there we go. So as you can see, it's really when you have bigger things, it's not gonna filter your water or anything like that, but you're at least getting the chunks to be more by themselves. Okay, and our last station is evaporation. Okay, so this is going to separate a solid mix into a liquid, usually in solution. So this was an example of some salt water solution. So it looked clear as it went in, and then as we left it on the heat source, you can kind of see that it crystallized all around your beaker. Okay, important thing to have on these is make sure there is a cover. You do want to kind of keep it from popping or anything like that. You can see that it also says you could use a crucible. That would be for maybe a smaller sample, and more of if you have sometimes a hydrate, which is a solid that just has water molecules in it, you can use evaporation in the crucible. Okay, but you would carefully, I would say, keep your heat at about 6 or 7. You don't want it totally going crazy. And the less liquid that you have to start with, the better off it'll be and the quicker it'll go. Okay, but you do need to monitor these very much. And then you just kind of scrape off some of the precipitate the best that you can, or the solute. There you go. And that would be evaporation.